Hello everyone, today I'm going to talk about learning pure mathematics. There is no royal road to geometry, said by Euclid famously. But that quote needs to be extended because there is no royal road to any branch of pure mathematics. Learning mathematics is fundamentally different than learning a physical concept. Because when you learn a physical concept, you can use your intuition. And that intuition is based upon of thousands of years of human evolution. And subconsciously, we are able to make connections between things that we can have a grasp on. By grasp on, I mean physically. But mathematics is like a language. It should be treated similar to learning a language. Because when you see a hard mathematical concept in abstract algebra or in topology, for example, you get scared quite fast because unlike, for example, a concept in GR, general theory of relativity of Einstein, you cannot connect, for example, the Ricci tensor, the curvature of space-time and the movement of objects. No. You have an abstract object, like a group. But what is a group? I can't touch it. I can only understand it by postulating concepts that aren't real, and actually I can, by changing fundamentally different things, obtain structures that are similar to it, but those structures, how do they differentiate, and what is the criterion of a rich structure and stuff, and it goes and goes and goes. So like learning a new language, you need to get exposed to it. And by getting exposed to it, for example, you don't understand every single word of a new language when you just started to learn it. But what you do is to get exposed to it constantly. Even if you don't understand it, subconsciously your mind somehow makes those connections, somehow gets the structure behind those words and how do they correlate with each other. And this is exactly the same in abstract mathematics. You need to keep on trying, you need to keep on not understanding. And eventually, like how your language intuition develop, your mathematical intuition will develop as well. But many physicists, when they move on to grad school, since they don't get a background in those abstract concepts in their undergraduate years, struggle a lot. And since they're accustomed to understanding quite fast and building intuition, they think that they are not gifted enough for mathematical way of studying, and they give up, unfortunately. But this isn't right at all. Many of the greatest mathematicians like Hilbert, over the years and years and years of studying, you can only get that intuition, and after you got that intuition, you can build upon things that are abstract, unlike the physical theories. So keep on getting exposed and keep on not understanding. Keep attending to lectures. Keep on attending to seminars and see how those mathematical concepts are applied into your field in physics, for example. It's like learning a word. For example, apple in German. You want to learn the word apple in German, Apfel it is. But to really learn it, you need to go to the market in Germany and deduce that word from the context. And that is actually the learning process of a language. You get inside it, you make mistakes, you forget it, and you just learn it again, asking questions. This is the way to mathematics. And I'm holding a book, Mathematical Foundations of Quantum Mechanics by Johnny von Neumann. This is an example. Physical theories like quantum mechanics are rich with mathematical structures. Quantum mechanics first built upon matrix mechanics by Heisenberg, then it actually shown by von Neumann that it is much more broad, and it actually accelerated the development of a field called functional analysis. What I'm trying to say is that while Heisenberg was developing his version of quantum mechanics, which is now formally known as matrix formulation of quantum mechanics, he didn't know about linear algebra. While showing his work to his supervisor at Göttingen, Max Born pointed to him that there is some rich structure that might resemble linear algebra. Then he learned it. And you know, Heisenberg was a graduate of a mathematical degree in Germany, so he was actually a mathematician, then switched to physics. And even he didn't know linear algebra at first, but he eventually learned it. So keep failing, keep failing, keep failing. Eventually, you will get it.